This video will discuss how to verify triangle congruence when given a value of a variable. For example 1, I see that the variable p is given as 10 and the variable y is given as 12. I also have a congruency statement that's shown here, triangle BOX is congruent to triangle ING. What I don't see is a figure. So what I would do is I would go ahead and draw it myself. So I'm drawing two triangles that are next to each other. And for the first triangle, it says that its name is BOX. So B is on top, O, and then X. So I is in the first position, N is in the second position, and then G is in the third. Now I want to go and look at the information that is given, and then I want to label it on my triangles. So for the measure of angle B, I'm told that it's 60 degrees. For the measure of angle I am told that it's the expression 5y degrees. For side or segment BO, it is shown as 6p minus 4. Segment BX is 4p plus 2. Segment IN is 3p plus 26. And finally, segment IG is 42. So I'm going to go ahead and notate that. And now let's go ahead and solve for the information that's shown to the right. For the measure of angle I see that I have 5y. I'm given that y is 12. So 5 times 12 is going to actually be 60 degrees. Measure of angle I, it looks to be congruent to the measure of angle B. So that's good. They're both in the first position in my congruency statement. The measure of an angle is measured in degrees. So now I want to try to find side BO. Well, BO was shown as 6p minus 4, and we were told in the given that p was 10, so we're just going to replace that p with 10. And after I simplify segment BO, I see that 6 times 10 is 60 minus 4 is 56. Sides are not measured in degrees. Now I'm going to look at side or segment IN, and that's given as 3p plus 26. So again, the p was given as 10. So I'm going to replace that p with 10 and then just follow the expression that was given. IN is 3 times 10, which is 30. 30 plus 26 is 56. So what I notice is both segments are congruent. So I'm going to annotate that on my figures with tick marks. So sides are annotated with tick marks and angles are annotated with arc marks. So now I have a side and an angle. Segment BX was given as 4p plus 2. So I'm going to do the same thing. I'm substituting in for p, 10 plus 2. So segment BX is 4 times 10, which is 40. 40 plus 2 is 42. So BX was in positions 1 and 3, and triangle ING has I and G in positions 1 and 3. So I'm looking at those sides and seeing whether or not they are in fact congruent. And based off of what I just found with BX, I see that they are. So BX is congruent to side IG. So now I can go ahead and I can prove that triangle BOX is congruent to triangle ING based off of side, angle, side. And it has to be true for both side, angle, side. So SAS is what I'm going to write in this blank above, side, angle, side. That's what that means. For example 2, I now have figures shown and I still have my congruency statement, which is triangle GAR is congruent to triangle DEN. I just have to prove, is that true? So what I'm going to do is set segment DE, which is 2y plus 1, and it's shown as my first and second, in the first and second position of my triangle congruency statement. 2, I'm going to look over at GA, and I see it's given as 15. This is one way. I didn't have to do it this way. I could have actually set DE and EN, set those equal to each other, but this is just the way I'm going to do it to compare the triangles. And now I'm going to have 2y is equal to, subtract 1 on both sides, that's 14, and y is 7. So I can go ahead, if I wanted to, and substitute that information in so that I can find the actual side lengths for segments DE and segment EN. So I see that DE is 2 times y, but we know y is now 7 plus 1, and it's going to be equal to segment EN. I already know that again because of the tick marks. And so for segment EN, we have y plus 8, but y is currently 7 plus 8. And equal means they're going to be exactly the same, right? So 2 times 7 is 14. 14 plus 1 is 15. And then on the other side, 7 plus 8 is also 15. So that checks out. Let's go ahead and fill in the blanks over here for those side lengths. And now let's go back to the angles. So we're looking for measure of angle E, which is given as 12x plus 18. Now we already know what the x value is because it was already given. So what we can do is for the measure of angle E, just go ahead and substitute in. So 12 times 9 plus 18. And 12 times 9 is 108. 108 plus 18 is 126 degrees. So notice a few minutes ago, I just said 15. I didn't say 15 degrees because it was a side length. This is an angle. I know because it says the measure of an angle. So I will annotate this with the degree symbol. Now, what I will notice is if I'm looking at my congruency statement, angle E is in the middle, and so is angle A for the other triangle. So when I look at angle A, I see it too is 126 degrees. So that's awesome. I know that both of those are congruent, so I can go ahead and mark it. At this point, I can clearly see that I have side, angle, side. What I do to one side, I have to do for the other. So GA and DE go together. So I would have another side and angle, and then AR and EN go together, another side. So side, angle, side. That's one way. If I really just wanted to prove it and stop, that's what I would write. But I'm going to keep going because there's another way I can prove it. Based off of the information that I have, measure of angle R is going to equal 3 times x. Well, x is given as 9. It's going to be 27 degrees. And again, this is an angle, so we are going to use that degree symbol. Now, there's 2 ways that I can figure out the next angle that's being asked for, which is the measure of angle D. Because if I look at my congruency statement, I see for angle D, it is in the same position as angle G. But when I look at angle G, there's nothing there, right? So I don't have anything for D or G. What I can do is one of 2 things. I can recall over at measure of angle E that this was 126 degrees. And I know that the triangle sum theorem says that if I add each angle together, they should equal a total of 180 degrees. So what I could do is just take 180 degrees and subtract what I do know. I already know that 126 plus 27, if I take that information and I simplify it, this is going to leave me with 27 degrees. So that's the triangle sum theorem. The other thing that I could recognize is that I actually have what's known as isosceles triangle. And isosceles triangles has 2 congruent sides. And the isosceles triangle theorem says if 2 sides are congruent, then the angles that are opposite of them are also congruent. So I usually just draw like an X. So that means that both angle D and both N in this particular triangle are going to be congruent as well. We already know the measure of angle N, so therefore we know that angle D is also 27 degrees. If I were to add all of those up, I would in fact end up with 180 degrees. So the measure of angle D is 27 degrees. The measure of angle D and G are both 27 degrees. So I could go ahead and put that here if I wanted to. We already know the measure of angle R is 27 degrees. We already figured that out a long time ago. So in addition to that side angle side, since I know that the measure of angle R and N, because they're both in that third position, are going to be congruent, I can go ahead and mark those with double arc marks. I wouldn't use single arc mark because that would indicate that they're the same measure as A and E, and they aren't. So now if I'm trying to find my other triangle congruency proof, I could say I have an angle, side, and an angle. I went in a specific order. I went angle A, side AR, and then angle R. So angle A would go with angle E, and then I said side AR, so that would go with side EN, and then I said angle R, which will go with angle N. Angle, side, angle. So yes, it matched in both of my triangles just like I thought it would. So that is what I'm going to write in the next blank. Angle, side, angle, and that is it for the video. Please like and subscribe. Have an awesome day.